Good morning, grade 11. How are you? Hope you are fine. Welcome again at your school at Osama International School. This is Sara Osama with you. Today we will finalize the last lesson in this quarter. Okay. It's also in chapter 22. Okay. Talk about polymers. Polymers. Okay. What the meaning of polymers? Look at the pictures now. Okay, look at this compound. For example, this is ethene, methyl ethene, methyl ethene. Okay, we have a side chain methyl and two carbon atoms ethene. Okay, so we have one molecule of methyl ethene, another one methyl ethene. When they combine together, okay, they will form polymers. The polymers considered as repeating units. Repeating units. For example, these polymers contain 2 units. Maybe another one contain 10 units from methyl ethene. Okay, this is called polymers, repeating units. Okay, the repeated units is called monomers. When the monomers combine together, they form the polymers. Okay, so let's see the definition of the polymers. A very long molecule composed of repeating units connected by covalent bonds. Okay, so repeating unit connected by covalent bonds. In monomers, the repeated unit, this is called monomers. The unit itself is called monomers. Okay, so again, the polymers, very long molecule, okay, composed of repeating units. Okay, the same unit, but we repeat. The repeated unit is called monomers. The monomers, a repeated unit in the polymers, reacted for the polymerization reaction. Okay, let's see another example. The previous example. Okay, so the one of the methyl ethene, this is called monomers. One, the black one, okay, this is called monomer, and the red one is called monomers. Okay, monomer plus monomers form polymers. Okay, monomer plus monomers form polymers. Okay, we have different kinds of polymers. Okay, we talk about the structure. First of all, the structure of the polymers. We have a skeletal structure and chemical structure. Okay, we have different kinds of skeletal structure and different kinds of chemical structure. Start with the skeletal structure. The first kind, liner. Okay, liner structure. This is a skeleton. Okay, a chain with the 2 ends. Chain. We have a chain, for example, here. Look at here. Repeated units. Okay, with the 2 ends. 2 different ends. Okay, OR and OR. This is the end, our start, and this is the end. Okay, so this is called liner structure. Liner structure. Repeated unit with 2 ends. Okay, repeated unit with the 2 ends. This is called liner structure. Okay, the second type, branched structure. Okay, branch means have side chains. Okay, for example, we have a line structure. On this line structure, we have side chain. So this is called branched structure. Branched structure. Okay, we have, for example, the repeated unit CHH, CHCl, CHH, CHCl, and so on. This is the repeated unit. Okay, and once at one, for example, at here, for example, at this carbon, we have a side chain here and side chain here. Okay, so this is called branched structure. Branched structure. Okay. Third type, cross-link structure. Cross-link network, formed as a network. Okay, cross-link structure. Okay, the chain are connected to the other chain. We have a chain connected through covalent bond also with the other chain. So form like the network. Okay, form a network is called cross-link structure. Cross-link structure. Different chains connected together with a covalent bond. Okay, again we have a liner structure. First kind, liner structure. Okay, repeated unit with the two ends. This is called liner structure. And branch structure, liner structure with a side chain. This is called branch structure. And the third type, cross-link structure. Different chains connected together through covalent bond to form like a network. Okay, this is called cross-link structure. Okay, so in the skeletal structure, now we said from the beginning, we have a skeletal structure and chemical structure. Skeletal structure, we have more than 3 types, okay, but in this year we'll study only 3 types. Skeletal structure, we said liner, branch, cross-link, okay? So the skeletal structure, we have liner, skeletal, and, cross-link, and branch. Chemical structure, let's study the chemical structure. Homopolymers. Homo means like homogeneous, okay? Homo, one type, monomers, okay? Homopolymer contain only one monomer and repeat. One kind only repeated, okay? So homopolymer contain only one type of the repeating units, one type. For example, if you consider the first polymer is A, all the polymer will containing A, no B, for example, okay? The same kind of monomers, all of them. So it's called homopolymers. Copolymers, co, more than one monomers, for example, A, B, okay? Copolymers, okay? We have two kinds of copolymers, alternating and block. Alternating, for example, two kinds of monomers, A and B, A, B, A, B, A, B, okay? Or, for example, AA, B, AA, B, B, okay? This is called alternating, okay? Alternating. And copolymers contain more than one polymer. Contain more than one polymers, okay? And the copolymers, maybe it will be alternating or block. Alternating like AB or AABB, okay? Or block. Now we have a block of A, for example, 5 units, 5 monomers of A, and 5 of B, 5A, 5B, or more than 5. This is another example. For example, we have 7, 7A, 7B, 7A, 7B. So we have block of one monomer and another block for another monomer. Okay, block of A, block of B, block of A, block of B. Okay, this is called copolymers. Once it contains more than one polymers, it's called copolymers. If they are the same kind of monomers, they will be homopolymers. Okay, they have the same type of monomers, all the chain, the same type of monomers. This is called homopolymers. If they are different kind, copolymers. And it will be alternating or block. Okay, so again, we studied there from the beginning the structure of the polymers. Okay, skeletal structure or chemical structure. Skeletal structure, we said it will be liner, branched, cross-linked. Okay, chemical structure, homopolymer or copolymers. Homopolymer, if they have the same kind of monomers, only one type of polymers. Copolymers, if they have different kind of polymers, different way, connected in a different way, alternating or block. Okay, we'll come another one. Okay, this is the structure of the polymers. Okay, skeletal and chemical, and we talk the type of the skeletal and type of chemical. Okay, you have any question? Okay, we'll study some examples of polymers. Some examples of polymers. Okay. First, look at here. The polymers, maybe you have polymers in your inside your body. Okay, the food. Okay, sometimes this is the natural polymers, and sometimes it will be human-made polymers. Okay, for example, this protein polymers. Protein is considered as polymer. Okay, so what the name of the monomer of this polymer? Amino acid. Okay, we have amino acid, repeated unit. It forms a polymer which is called protein. So the polymer, for example, protein, it contains monomers called amino acids. Okay. For example, starch. Okay. It contains monomer sugar. Repeated unit of sugar, it will form the polymer starch. Repeated unit of sugar will form the polymer starch. Okay. This is of course natural polymers. DNA inside your body. Okay. This is the polymer, considered as a polymer, okay? It contained 4 different nucleotides, okay? So it will be copolymers, okay? The sugar or the starch here is homopolymers, homopolymers. This kind, because it contains more than one type of monomer, this will be copolymers, okay? So DNA, starch, protein, example of natural polymers, okay? We have another example, polyester. Polyester, this is a polymer, okay? A monomer of this polymer, an alcohol and carboxylic acid. So they are different kinds, 2 kinds of monomers. So it will be which kind of polymers? Copolymers. We have 2 repeating units, alcohol and carboxylic acid. To form the polymer is polyester. This is of course a human made, okay? So we have an alcohol and we have carboxylic acid, monomer alcohol, monomer carboxylic acid to form the polymer polyester. Okay. Another example of a human-made polymer, plastic. The plastic kind of alkene. Okay. The monomers of the plastic, alkenes. Alkenes double bond. Okay. Alkenes double bond. Okay. This is also human-made. See another example. Polyethylene. Polyethylene. Okay, like the plastic bottle of the bags, plastic bags. Okay, we'll take some properties of the polymers. For example, polyethylene. Polyethylene. The repeating unit from its name, ethene. We said the plastic comes from alkenes. Okay, so polyethylene. This is waterproof, flexible, like the bag, strong, low density, insulator. Okay, some properties of polyethylene: waterproof, flexible, strong, low density, insulator. Okay, electricity insulator. Okay, polypropene. Polypropene. Another kind, but a kind of alkenes also, but 3 carbon atoms. Propene. Okay, cheap, strong, hard and flexible, shatterproof. Okay, this is polypropene. Okay, polyethylene, 2 carbon atom, polypropene, 3 carbon atom. Okay, BBC for polychloroethylene. Polychloroethylene. Okay, this is waterproof, okay, tough, good insulator, hard or flexible walls, okay, like the wires, okay, and like the door and windows, okay, waterproof, tough, good insulators, and hard and flexible form. Teflon, okay, of course you use Teflon in your kitchen. Polytetrafluoroethene, okay, so sorry, the Teflon polytetrafluoroethene. Tetrafluoro means it contains four atoms of fluorine, okay, polytetrafluoroethene, two carbon, C and C, contain each one contain two fluoro, so tetrafluoroethene. This is the Teflon, okay. It's also tough, slippery, okay, non-stick, low reactivity, not reactive with the food, okay. This is some properties of some kinds of polymers. We have a lot of kind of polymers, okay. We just mentioned some kinds. Okay, the last part, how to compare between the natural polymers and synthetic polymers, okay. The natural polymers existing in living things, okay, in the nature, okay, from animals, plants, inside your body, like DNA, okay, like protein. Okay, with some examples, protein, we said the monomers of protein, amino acids. The amino acid is the polymer, and protein, the final polymers. Carbohydrates, glucose, the monomers. Carbohydrates is the polymers, okay. Natural rubber, isoprene, this is the monomers. Natural rubber, this is the polymer, okay. Again, the natural polymers exist in living things, okay. We found it in the nature, inside the plants, inside animals, inside your body, okay. Synthetic polymers, okay. This is a human-made polymers. Human-made polymers. Polymers that are man-made, human-made, by the chemical process in the lab. Okay, you can prepare this kind of polymers inside the lab. Okay, many of the raw material for synthetic polymers are obtained from petroleum. Most of the common polymers, synthetic polymers, come from petroleum, okay, after refining and cracking process. For example, like the plastic, we took some examples of that plastic. Fibers, okay, like plastic, we said the monomers of the plastic alkene, like the polyester, okay, this is kind of fibers, okay. Elastomers, two type of polymerization, addition polymerization and condensation polymerization. We will not talk about this kind of reactions, but preparation of the polymers, you will not take it, okay? Just I want you to understand what the meaning of polymers, okay? And the structure of the polymers, it's a repeated unit of monomers, okay? Again, so in the beginning, we talk definition of the polymers. We said the polymers, the very long molecules composed of repeating units. This repeating unit is called monomers, okay? And we talked about the structure of the polymers, skeletal structure, and the chemical structure. Skeleton, we said the fit liner structure, repeated unit with two ends, okay? So liner structure, okay? Repeated unit with the two ends. And branched structure, okay, has the side chain. Any chain, liner chain, and if it has any side chains, this is called branched structure. And cross-link structure, okay, this is a chain connected together through covalent bonds, okay, to form like a network. This is a cross-linked structure. And we talk about the chemical structure, homopolymers and copolymers. Homopolymers contain only one type of monomers, okay? Like this example. If copolymers contain more than one type, it will be connecting, alternating, or in flux, okay? Copolymers contain more than one type of monomers, okay? And we have some examples of polymers, as we said. We have natural polymers and synthetic polymers. This is some properties of the monomers. And this is a comparison between natural polymers and synthetic polymers. Okay, if you have any question, this part of polymers, it will be useful in your research. Okay, you have to read a lot and you can search which kind of polymers we use in bridges. Okay, which kind of polymers we use in bridges. You have to find the answer to this question. Okay, thank you for listening and happy Ramadan, inshallah. Ramadan Kareem for all of you. See you in our meeting, inshallah, after 2 weeks. If you need any help, just call me. Okay? Thanks. Before you leave, you have to watch this video to stay safe.
Nope. Yep. 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 Nope. Yep.